Good evening, welcome to the STEM Shed. Today we're going to be going over unit vectors. I kind of have the basic formula you guys have been taught right here. You get the U with the arrow is equal to the A with the arrow over, you might, it looks like an absolute value sign like this, but I like to do the double marks to signify magnitude, because you get confused a lot of times when you have that, just think you think it's absolute value. And then you'll get something that says I plus J. Alright, so what does it mean? Well, first off, let's start with what is a unit and what does it do? So I've run an example here. It says you drove 40 miles east. Alright, so what's the unit? What's a vector? What's a scalar? You know, so I wrote again here. It says you went east 1 mile 40 times. So in here we have direction. This is our unit, 1 mile, and you did it 40 times, so this is our scalar. So this is our scalar. He went 40 miles east. You might say, well, this is a weird way to say things, but if you've ever ran, like, say, a 5K, you're like, oh, I just ran 1 kilometer. This is so hard. I gotta go another kilometer. Well, I gotta do 1 kilometer 3 more times. Something a lot of times people do to kind of pep themselves up. So going back to here, I'm going to get rid of this. Alright, so what's probably happened at some point is you've been doing your vectors, you know, if you're in pre-calculus, you're in 2D, and you're probably doing something that looks like a X, Y, or you might be doing like a I plus J. Alright, well, so you'll get that, and let's go back to the I. You'll get something that says like a fraction I plus, we'll say, whole number J is equal to blah blah blah. Alright, you'll get something like that. Alright, and that's equal to your unit vector. Well, what does that even mean? Well, what they're doing here is scaling it for you. And to maybe better give you an example of how you can confirm what you're being taught is, go back to something you know, the unit circle. You know what a unit circle is. If you're in pre-calculus, you know it. If you're learning this, you've probably gone over a unit circle. So I'm going to go into that assumption. So what we have here is I'm going to draw out a circle. So we got one circle here. Alright. And you've done the unit circle, so you're probably used to this. And if you look, you'll get something that looks like this. Again, I don't draw the scale, because I don't care. So, and you'll say, okay, this is 1. And if you've done this, you've written something here that says like, you'll have, in this case, 1/2 and square root of 3 over 2. 3 over 2. Alright, so you have square root of 3 over 2. And you might kind of, you know, other than memorizing where this is at, you might kind of remember, okay, well, this is this one right here. And then you'll remember that this one right here is going to be this one. Alright? Well, this is the same as your x vector. And this is the same as your y vector. I just didn't assign x or y to here yet, but that's generally what you mean. I could have done that. And this is what it means. This is a 1/2 inch this way. And this is 3/4 of a 1/2 inch. Which is, remember, still below 1. Can't be over it. You get that. But what if we gave you a unit circle, or gave you a circle that was much larger? Like this, for example. Now again, not to scale. I don't do scale. I'm not a really good artist, as you can probably tell if you see my other videos. But let's just say we got something like this, alright? So we have this, and we're going to say this is 5. So it has a radius of 5. Alright, excellent. So I'm going to go back here, and I'm going to do the 3-4-5 rule, because it's easy for me to remember. 3-4-5 rule is something I learned when I did construction when I was a teenager. So I had to do construction. It was hard labor, but I learned something kind of cool. And let's go with green. And then you go this way. Alright, so if I go 3 inches this way, 4 inches that way, I get 5 inches that way. So, and again, you know, it's something simple. Just kind of remember 3-4-5, 3-4-5. So if you did Pythagorean theorem, 3 squared plus 4 squared gives you 25. Square root of that gives you a radius of 5. So going back to that. let's see. Yeah. So if we did this, if we chose this one here, we want to find a unit vector, which is just going to give us our one scale to it. Same way we got our scale for the 40 miles. You're going to get, alright, so you're going to have u is equal to, so let's see, we're going to put a vector here, and let's see, we got x direction 4, y direction this, and remember, we have to do the magnitude here, so we get a 4 squared for the x, plus 3 squared for, 3 squared for the y, alright, and that is going to equal to, and I'm going to bring this down here, and that is going to equal to, when you do all this, remember this goes to square root of 25, or 5, alright, so this goes to square root of 25. So in engineering notation, you're going to end up with this, 4/5 I plus 3/5 J. You're like, okay, well I know that. I know how to follow directions. Directions are easy. But what does it mean? Alright, well this is what you got to scale by to get to your unit vector of 1. This is what you have to scale in the x direction and y direction. So if we did that, if we go back to, let's see, I'm going to use a black marker because I know you can see it. Pythagorean theorem. C squared is equal to b squared plus a squared. Go c squared is equal to b squared plus a squared. Then you're going to end up getting, or if we want to go to the unit circle, x squared plus y squared is equal to r squared. Well, let's put these in. We got 4/5 squared plus 3/5 squared is equal to r squared. Well, lo and behold, what's this? We get 16 over 25 plus 9 over 25 is equal to r squared, which is equal to, again, 25 over 25, which is equal to 1, and that is equal to the r to square root. Take the square root, r is equal to 1. Now you're back here. That's all it is.